Greeting everyone. I am TS Dr. Muhammad Azim. Thank you for joining today's webinar. Today's topic is about global machine control. So this is a learning outcome. So by the end of today's webinar, the participant should learn about what is the meshing, process for processing using ANSYS tool, meshing fundamental, how to launch ANSYS meshing, ANSYS meshing interface, geometry concept, and meshing method. Okay, so we begin with the introduction of meshing. For your information, meshing is one of the most important step in the performing an accurate simulation using finite element analysis. By definition, meshing is a process of turning irregular shape into more recognizable volume called element. So meshing is one of the key components to obtain an accurate result. So basically, meshing consists about 75% of the simulation. The rest is a boundary condition. Okay, as you can see here, there are 5 3D element type, which tetrahedron, hexahedron, or also known as a brick. And then we have a prism, a pyramid, and arbitrary polyhedron. Okay, these 5 elements can be used in a various combination to mesh any 3D model. Okay, and then for 2D model, we have a triangular and quadrilateral element. However, we don't discuss 2D very much here. Okay, as you know, tetrahedral element are default element type for most physics. Then tetrahedral also can be meshed with normally tetrahedron is our first choice. Okay, and then for the other type element such as hexahedron, prism, and pyramid should be used only when it's motivated to do so. It is first worth noting that this element will not always be able to mesh particular geometry. The primary motivation to use the hexahedron and prism element is to reduce the number of elements in the mesh. Okay, and then for the pyramid, are only used when they're creating a transition in the mesh between hexahedron and tetrahedron. Okay. The main objective when performing meshing is to obtain the high accuracy and short processing time. However, it's difficult to obtain the perfect balance between computational time with accuracy. So basically, the quality of mesh depends on the several aspects, such as the type of analysis and preparation time and solution time. Usually, smaller mesh mean more accurate result, but the computing time get significant as well. Sometimes the computing time increase double just to improve only 1% accuracy. So it's not worth it. So this diagram show the process flow for the finite element analysis. As you can see here, the first step is the geometry preparation and meshing. the detail for the processing workflow is shown here. So as you can see here, first we start with the geometry. So this one we can create by using the for example use design modeler or space claim in ANSYS. And then after that, after we prepare the geometry, we need to make sure that the geometry is we need to clean up and repair before it's applicable for the simulation. Then after that, we need to prepare the meshing. So here today we want to focus on the global meshing and this type of mesh. So this is two approach to parameterize a mesh, which is a global meshing and local meshing. Okay, so this is the feature that are available in global mesh control and local mesh control. In the global mesh control, we have these features such as assembly, advanced differentiating, patch confirming, inflation, statistic, sizing, and default. And then for the local mesh control, we have this function such as method control, sizing control, contact sizing control, inflation control, pitch control, method phase meshing, gap tool, and refinement control. So there are several situations that when we need to use whether global control or local control. So the first situation, let's say using a big global mesh. So this one, for example, because this one, I don't really care much about the result right now. Just give me approximation. And then the second situation, we using a small global mesh when I really don't have time to set this simulation up properly. I have too much time or computation resource. Okay, this is a situation when we use the using the small global mesh. Okay, another situation is when we use using a small local mesh in some area. Okay, because this one I know which area are critical for my analysis, so give me approximate result everywhere, but give me accurate result in the particular chosen area. And then the last situation is we use using a big local mesh in the some area. So for this part, that means I don't care about the result in this part, but give the accurate result over the rest of the body. So this is a four situation that make us decide whether to use a global control or local control. So basically we can conclude that we use a global mesh control for the very fast processing, and then to quickly get a sufficient mesh, and then as the result, the mesh will be same everywhere. And then for the local mesh control, it's different from global mesh control. Okay, basically local mesh control require more effort in meshing, and then construction mesh around area of interest very quickly, can get a very efficient mesh at the cost of time spent machine, and then the last one is give a better control of mesh. Okay, so let's start with the demonstration. So this our workbench. So I already drag the geometry and input geometry model in this part A, and then I link the geometry with the mesh. So so this is our model. So first, what you need to do is to check the unit. So make sure that is the correct unit. So for this one, I choose millimeter, kg. This one, I choose this one. So this is the outline. You can see here got one brush here is related to mesh. So you can click mesh. Okay, so this is a global mesh control. So if you click the mesh option at the top here, you can see several options for local mesh control. This one you can see here. We have a method, sizing, face meshing, and so on. This is this one is a local mesh control. But for today we focus on the global mesh control. So okay, this is a global mesh control. So as you can see here, before that I want to generate the mesh first with the default setting. So to generate the mesh, you click here, generate mesh. So it will take some time processing time to generate the mesh. So after that you can click here to show the mesh. Okay, we go back to the detail of mesh here. So as you can see here, here got several features such as display, defaults, and then sizing, quality, inflation, batch connection, advanced, and statistic. Okay, so okay, the first one is the display feature. So for display feature, actually it's related with the quality. So here I have several options. So so you can select you can choose one of the options here, but let's choose screeners. So this is this we show the screeners, and then this is the range. It's similar as okay. Let's set to the user geometry thickness setting, and then go to the quality. So actually the previous one is show the result from the screeners. So this is the data that we obtain. So this statistic show the number of element versus the element matrix. So okay, later I will explain about the mesh quality. Okay, but the display you can use to show the sorry, you need to select none first. and then you go back to the original display. So this actually this show the quality of the mesh based on the squeeness. Okay. Now I go back to use geometry. This is default setting. Okay. At the default setting, you have three feature. The first one is a basic preference, and then element order and element size. Okay. For the basic preference, got a 7 option here. So from the mechanical, nonlinear, mechanical, electronic, CFD, explicit, custom, beta, and hydrodynamic. So actually, so you need to choose the suitable model based on your problem description. So you need to carefully select the basic preference because the mesh setting setting default will be automatically adjust to the basic preference and solver preference. Okay, let's say I click a CFD. You see here. Now the option is changed already. So same for the CFD, the type of solvent have a 3 type, which is fluent, CFX, and polyflow. But for today, I'm stick with the mechanical. Basically, you can choose other basic preference based on your problem. So, but for today, I only focus on the mechanical. Okay. And then the second feature is the element order. So for element order, you have whether you leave to the program. These three options: program control, linear, and quadratic. Okay. So for the element order, you have to type, okay, which is the linear and quadratic element. So linear element is for element that do not capture bending, but for the quadratic, a better suite to represent the complex geometry and bending deformation. So as you can see here, tetrahedron is a lower, so that means it's a linear. And then hexahedron is the higher, so it's the best on the quadratic. So for the lower, have a less accurate, but hexahedral is most accurate. But this one, of course, tetrahedron is less expensive because it take short processing time compared to the hexahedral. Okay, element size. The next is element size. So in element size, you can leave it as a default. Okay, this is a default setting. You also can input any value here. So the value in the millimeter unit. So based on the unit lah, you select. So let's say I change the unit to 2 mm. and then click generate. So it will produce a smaller mesh element. Okay, you can go to statistic and check the number of node and element. Let's say I reduce the element size to 1 mm. So we can expect the number of node and element will be increased. So now I click the generate. Okay, you see here. So the number element is increased from drastically. So now you produce a finer mesh. So if you want to go back to the default setting, just input 0 here, and then click generate. So you go back to the default setting. Okay, now the next, so we already done with the display and default setting. Now we go to the sizing. Okay, so for the sizing, we have one option here. One feature here is use ability sizing. Okay, for use ability sizing, got two options, whether yes or no. Okay, what is mean? Ability size. Use ability size. What is mean? So actually, if you for the default setting is a yes. This one yes is a default setting. Okay, this one when if you want the sizing generate based on this um, following sequence. Okay, if you click yes, it will follow this following sequence. Okay, so if the mesh will be generated based on this following this sequence lah. The mesh we base mesh with the edge mesh with the global element size, and then after that the edge refined for the curvature and 2D proximity. At the end, and then after that at the end the corresponding phase and volume mesh is generated, and the lastly transitions offset is defined by the transition. So actually for yes it's automatically generate. So okay, also you can select no. If you select no, you have to input manually for curvature and proximity. So this is let's say this so if you select no, two options will be come up here. Capture curvature and capture proximity will be appear. So that means you need to input. You need to use these two options lah. Okay. But before that, we go to the growth size. Okay. What is the growth size? Growth size mean the higher growth rate increase the mesh element. Okay, actually you can put any value here. Okay, this is a for grow rate. So grow rate is a transition between small and large size based on the specific grow rate. So the grow rate represents the increase in element edge length with the edge subsidy layer of the element from edge or face. For example, a grow rate 1.2 result 20% increase in the element edge length with the edge subsidy layer of the element. Okay, actually you can cut can see here if you increase the let's say we change the grow rate into 1.8, that means it will produce a bigger mesh volume. Okay, max size is the maximum size of an element. Okay, but this one is the average element. This one element size actually is a average. Now the average element size is a 3.7749, but the maximum element size is a 75498. Okay, this is a default, but you can set the maximum size of element. You can put any number here. And then we have another feature here is the mesh diffusioning. So mesh diffusioning mean that it can remove unwanted geometry from the model. For example, this one. Let's here got a detail from the geometry. So by activate the mesh diffusion, the software will automatically remove the detail. So you also can remove other details such as a fillet and so on. So actually you can also put so you can set the any value here. So so the feature size determine the size of feature that the mesh generate, and the size under that value will be ignore. Okay, but this one you can ignore. Okay, and then okay, the next feature is the capture curvature. So you see here have a at this geometry have a curvature here. Say now the curvature is very not good. The surface is not good, but we can refine this part by select yes, and then by select yes you have there will appear two options, curvature mean size, and then curvature normal angle. Okay, okay, we try generate the mesh by this setting. Okay, but okay, at the moment the default setting is for the conversion normal angle is 70.395. Actually, we can refine this part by reducing the conversion normal angle. Okay, so at the now at the moment the normal angle range for our model is 70 something. So so that means it's a cost. Okay, but we can change to the we can change the angle to let's say we select the number between 36 to 12 degree to get the final mesh. So we try to change this setting to let's say 20, and then click generate. So now it will produce a better final mesh surface here. So so this is a function for the conversion normal angle. So you could put so got a certain range lah to improve the mesh in this part. And then conversion mean size, you can set the minimum size for this surface. But now I leave to default setting. Okay. Okay. The next one is the capture proximity. So same as the previous one. So you can either select no or yes. Okay. So the main function of the capture proximity to produce the number of element across a thickness. Okay. You see here. This have here got a thickness. So this part also have several thickness. Let's say I turn on the capture proximity. Two option, two feature is appear here: proximity minimum size and proximity gap factor. Okay, so by the default setting, you have here is a 3. Okay, so that means you can see here the number of layer is here is a 3, 1, 2, 3. So if we change the, let's say we want to get let's say minimum number of layer is 5. Okay, we change this proximity gap factor into 5 and then click generate. So the number of layer will be increased. Okay, now it produce more. It produce about 1, 2, 3, 4, 5, 6, 7 layer. So so the number of layer is more than the minimum 5. So same with the this part lah. Okay. Okay. So you can either okay, this you can either leave this you can select no for both capture conversion and capture proximity, but you can also select yes for both capture conversion and capture proximity. So this option is based on your problem. So you can either turn either one on or turn one off. Okay. So the other portion, I think you can. It's not important. Okay. So how do we know that our mesh is okay, is acceptable or not? Okay. Actually, you can go to the here quality. You can check the okay. So you go to mesh metric to check the mesh quality. So there are several so many choice available here. So for example, we have element quality, aspect ratio, Jacobian, maximum corner angle, squeeness, minimum triangle, maximum triangle, and so on. Okay, so let's say we want to choose one of the um, let's say we choose the element quality. Okay, the bar chart will be generated lah here. So you can see here the number of element is this one. The red one is represent the tetrahedron. So you can see here our model have many element based on the tetrahedron, and then the blue one here, the blue one is a hexahedron. So compared to the tetrahedron, the number of element based on the hexahedron is smaller. So what is the element metric? So the element metric is represent the quality of the element. So as you can see here, the quality of our mesh element is acceptable because for the if you use this type of element type of metric, which is element quality, is expected to get the element metric more than 0.25. So basically, in average, we have element metric is more than 0.5. So that means is our mesh is acceptable. Our mesh quality is acceptable. Okay, but you also can choose other type of mesh metric, which is a squeeness. Okay, so but for the squeeness, they have a different acceptable range. Okay, you can refer to this slide. Okay. Okay, so for the mesh metric, for example, like I explained before, element quality, the acceptable range is greater than 0.25. And then if you choose the aspect ratio, so one mean good. And then for if you choose a Jacobian, one also mean good. Then for the squeeness, okay, 0 is good, but 1 is poor. So hexahedron and quad cell squeeness should not exceed 0.85. And then for the triangle cell, the squeeness should not exceed also should not exceed 0.85. And then the last one is a tetrahedron. Tetrahedron also should not exceed 0.9. And then for the last one, mesh metric is a smoothness. The acceptable range is 1.2. Okay. Okay. The last one is we go to the inflation. Okay. Inflation is the refinement tool. Okay. Okay. This is okay. If you want to use inflation, you need to select the surface. Let's say I select this surface. And also I select this surface. So then I create a name selection for both surface. I name it as a whole. Okay, so here is the name the whole that I create here. So to use the inflation, okay, whether you have two option, whether three option, whether you select none, program control, and all face chosen in the name selection. So I already have a name selection, so I select a name selection. This one. So I click hold. Okay, so this one, let's say this is several option lah. So but the usually we select total thickness. Okay. 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 Let's say I want okay. I select. Let's say okay. I select 5 total layer. Maximum thickness for the is let's say I select 1 mm. So and then after that I click generate. As you can see here, it will generate a number of layer at the whole pipe. Here at the top and also a bottom. So you can count here, got 5 number of layer, 1, 2, 3, 4, 5. Okay, actually you can also change lah the number and also change the number of layer, change the grow rate and the maximum thickness based on your preference. Okay, okay, I think okay, I think that's all for me. So I want to conclude that meshing is very important. So because it's a foundation for engineering simulation, meshing actually influence the accuracy, convergence, and speed of the simulation. So you need to balance the number of element and the processing time so that you will achieve the accurate and stable solution. So I end my presentation. So I open for the question for audience.
Thank you very much, Dr. Azim. Before we move to Q&A session, I will launch a poll. Please select the appropriate response and click submit. So now Dr. Azim will answer some question. If you have question for Dr. Azim, you may raise your hand and turn on your microphone, or you can also submit a question via the chat features. So the first question is, what is the purpose of inflation? Dr. Azim, may you answer this question?
Yeah, so basically the function of the inflation is to refine the to get the final mesh at a certain pipe. So for example, I show is a hole. So we if you use inflation, we create a number of layer at the whole region. Okay, this feature is very important for the to get the better accuracy at the certain surface lah. Normally, this inflation used in the CFD application. That's all the answer for me. I hope answer your question.
Okay, does anyone have question regarding this topic? The next question is from Muhammad Musa. Dr. Azim, can we go directly to load the application even if the mesh has some problems?
Actually, it depends on the warning. Sometimes the warning still allow you to proceed to the solver, but in the certain case, you need to solve for the mesh part first. So it depends on the situation. That's all for. I hope I answer your question.
Oh, I missed the question from Javier Wong Chen. So is it similar to local mesh control, Dr. Azim?
Global mesh control actually is different from the local mesh control because for the global mesh control, we actually it's overall. It's regardless of the what the surface or the body part. But for the local mesh control, you want to do the mesh on the specific region, surface or body part. So it's you you want to get a more accurate mesh at the certain surface. So it depends whether you want to use a what I can say you use the local mesh control for the to get more accuracy at a certain pipe. But global mesh setting is for the general for the total body pipe. Okay. Any other question?
Yes, we got a lot of question at the chat features. From another question is the meshing control for shells element is similar as solid element?
Shell. So basically it's almost same, but we use that in the different situation. That's all for my answer. Maybe I go I come back and give more detailed answer to you later.
Okay, it looks like we have covered all of our question. Thank you again, Dr. Azim, for answering those questions and for the great presentation. Dr. Azim, is there anything else you want to cover?
Nothing from me. Thank you. Maybe we can have another webinar. We discuss about the local mesh control.
Yeah, great. Thank you, everyone. We appreciate you being here. Before we end, I would love to share with you about our upcoming event. Our first event is ANSYS Electronics webinar. This event will conduct on 29 September, and the next event is ANSYS Level Up 3.0 on 25 October. Be sure to mark your calendar to save the date. We also encourage you to connect with us on social media to get latest information. If you have additional questions, you may contact us by email, training@dfe-tech.com or telephone. We are happy to provide additional support. Thank you all for attending. We hope you have learned and enjoyed this presentation. Have a nice day. Thank you.
Okay.